Hi, in this video we're going to talk about atoms, elements, and the periodic table. This is going to be a brief introduction to chemistry. Chemistry is important for all sciences. Math, physics, chemistry are the building blocks of other sciences like biology and anatomy and physiology. So we're first going to talk about atoms. Atoms are the smallest particle of matter, and matter makes up everything. Matter is anything that has mass and occupies space. So when we're talking about chemical bonds, we're talking about biochemical molecules, we're talking about cells and tissues and organs. It all comes back to atoms and the atoms that make up those parts and how they interact. Now you'll hear me say the word atom and element, and for our purposes they can be used interchangeably. So when we talk about the periodic table of elements, we're talking about atoms. I also wanted to note that matter and energy are different. So matter, again, is the physical parts of the universe, so anything that has mass and occupies space. Energy, however, is a property of matter. So we usually talk about matter as things as solids, liquids, and gases. We usually talk about energy as the different types or forms of energy, things like kinetic energy, potential energy, light energy, heat energy. So I hear a lot of students say that ATP is energy, but really ATP is a molecule, so matter, that is capable of storing energy. So just keep that in mind. So this is the periodic table of elements. So atoms are arranged in this table of elements. And I just wanted to briefly show you how the periodic table of elements is organized. So each atom has its own little box. So for example, hydrogen, the symbol for hydrogen is H, and each atom or element has its own symbol. Some of them make sense, some of them are less intuitive. For example, Na is sodium. At the top of each symbol is a number. So for hydrogen, it's 1. That's called the atomic number. This number represents the number of protons in that atom. At the bottom, usually, of the symbol is the atomic weight. And being able to use the periodic table to recognize the atomic number and the atomic weight will become important later when we talk about chemical bonds. Atoms or elements are made up of subatomic particles. These subatomic particles are neutrons, protons, and electrons. I kind of think of atoms as little elements, or excuse me, as little planets. Inside the atom is what we call the nucleus, so it's the middle. And the middle part of an atom is going to include neutrons and protons. And orbiting around the nucleus are the electrons. So you can kind of think of the neutrons and electrons as the planet, and then the electrons are the moons that orbit around the planet. Protons have a positive charge. Neutrons do not have a charge, so they are neutral. And then electrons have a negative charge. Atoms have the same number of protons as they do electrons. And so when we talked about that atomic number earlier, that atomic number is also the number of electrons. So, for example, if we look at chlorine, you see that number 17 on top of the atomic symbol. So that is the number of protons, but since the number of protons equals the number of electrons, this also represents the number of electrons, which again will become important when we talk more about chemical bonds. And you'll see me use abbreviations for some of these. So I use E with a minus symbol to represent electrons, and I'll use a plus sign to represent protons. So when it comes to chemical bonding, the most important subatomic particle are electrons, and so that's what we are going to focus on, because chemical bonds are what allow us to then put these atoms together to build molecules. And in a biology or an anatomy and physiology class, those molecules are then going to build up into cells, biochemical molecules like carbohydrates, and eventually tissues and organs. So we're going to focus on electrons. So for our purposes, there's kind of a rule how those electrons are organized or orbit around the nucleus. So let's take oxygen, for example. So if we look at the periodic table, oxygen has an atomic number of 8. So again, that 8 not only represents the number of protons, but it also represents the number of electrons. So oxygen has 8 electrons orbiting around it. So if we draw, say here's the nucleus, so our protons and neutrons. The rule is that the first shell or orbit around that nucleus is going to contain 2 electrons. So those little dots are 2 electrons. Every subsequent shell can have 8 electrons. So we'll draw a second shell. Since oxygen has 8 electrons and we've already used 2 of those electrons in the first shell, that means that oxygen is going to have 6 electrons in the second shell. And an atom is stable when it has 8 electrons in its outer shell. So since oxygen only has 6 electrons in its outer shell, that means it's not stable. And that's not a bad thing. If we didn't have unstable atoms, then we wouldn't form chemical bonds and there wouldn't be life. So because the way that the atoms become stable is by either giving up electrons, taking electrons, or by sharing electrons with other atoms. And by transferring or sharing electrons, that's what allows atoms to form chemical bonds. And again, that's what's going to build molecules, macromolecules, organs, tissues, cells, things like that. We can do another example. So earlier we talked about chlorine having 17 electrons. So this is going to represent my nucleus. So in that first shell, it's going to have 2 electrons. That first shell can only contain 2 electrons. So then we've got 17 electrons to work with. So that second shell is going to have 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2 is 10. So we've got 7 electrons to work with in that third shell. So 1, 2, 3, 4, 5, 6, 7. So that's all of the electrons that chlorine has. So it only has 7 electrons in its outer shell. It needs 8 to be stable. So that means it's going to form a chemical bond with another atom in order to become stable. Thanks.